Alright, good morning. Today we're going to look at infinite geometric series, but before we do that, we're going to warm up from a problem from yesterday. I want you to write the following series in summation notation, and then notice I've changed B. I want you to, instead of finding the sum of the series, because it's an infinite arithmetic series, we want to find S10, the sum of the first 10 terms. So I'm going to start with the general formula for an arithmetic series is d times n plus a sub 0. And I'm going to find the common difference. So how did I get from 5 to 2? How did you get from 2 to negative 1? Hopefully you're all saying you subtract 3. Or you think about it as adding a negative 3. Adding a negative 3 every time. So adding the negative 3, that becomes our common difference. And then a sub 0, remember this is a sub 1, the first term in the sequence. So a sub 0 would be the term before that. And if we're adding negative 3 each time, if we go backwards, a sub 0 would be 8. So a sub n equals negative 3n plus 8. In your summation notation, that goes right in this big box here. That's our rule. And we're starting from n equals 1, because our a sub 1, 5, was our first term. And the 3 dots at the end means that it's going on forever. So a starting at 1 to infinity. And that would be in summation notation. For part B, finding the sum of the first 10 terms, we need to use the formula S sub n equals n times a sub 1 plus a sub n divided by 2, where n represents the number of terms we're trying to find. A sub 1 is the first term. A sub n is, in this case, it'll be a sub 10, the 10th term, because I want the sum of the first 10 terms. So wherever I have an n, I'm going to substitute in a 10. So 10, a sub 1 was equal to 5. We want a sub 10 there, divided by 2. So you're going to have to do a little bit of side work here and figure out what does a sub 10 equal. So you're going to use your a sub n formula, which was the negative 3n plus 8, and plug in 10 for n. So negative 3 times 10 plus 8. So negative 30 plus 8 is negative 22. So then 10 equals 5 plus negative 22 all over 2. I'm going to do what's inside the parentheses first. That's going to be negative 17 over 2. Dividing 17 by 2, I got negative 8.5. That times 10, I get negative 85. So the sum of the first 10 terms of this series is negative 85. Alright, so today we're looking at infinite geometric series. Can you find the sum of infinite geometric series? So consider a segment 1 meter long. We're cutting it in half. So 1 meter long segment, that's the blue segment right here. Then we're going to cut it in half. That's going to be the green segment. Then you're going to cut that in half again. You're going to get the red segment. Then we cut that one in half again. You get the yellow, and so forth. And if you took all of those segments from green all the way down to the black and keep adding them up, if we're adding them up forever, will it have a sum? And if so, how much will that sum equal? Well, first of all, let's think about this. If this is the blue is 1 meter long, then the green would be 1/2 meter long. Then half of that would be 1/4 meter long, and half of that would be 1/8 of a meter long, and half of that would be 1/16 of a meter long, and so forth. So what type of series is this? You're starting at 1, going to 1/2, to 1/4, to 1/8, to 1/16. Hopefully you're saying, this is a geometric series. Yes, this is a geometric. And it's going to be even more specific. It's an infinite geometric series because we can infinitely cut that piece in half. And even if we keep cutting on forever, what will the sum of all the lengths have to add up to? Well, hopefully you see, even if we cut this in half, if we add all these together, they're going to eventually have to add up to what you started with the blue. Like, that was the original length. It has to add up to that. But if you're not completely convinced, let's look at these first couple terms in the series, 1/2 and 1/4. If you did 1/2 plus 1/4, whoops, we get 0.75, 3/4. And then we add the next term in the series, which was 1/8. We're getting closer to 1, 0.875. If we keep adding up these terms, like we add the next term in the series along with that, 1/16. 0.9375. Then we add the next term. So now we're at like the first 5 terms in this series, 1/32. We get 0.96875. So even if we keep adding up forever, the sums are going to eventually have to add up to 1. So this brings us to our topic today. Do infinite geometric series have a sum? And if so, can we find them? Some of them do, and we can find them. So an infinite geometric series has a sum if and only if that common ratio, that r, is less than 1. These are absolute value signs around it. So that means you could have 1/2 or -1/2 because those absolute values of those are both less than 1. So as long as the common ratio is less than 1, the infinite geometric series has a sum. If your r is less than 1, then we can use this formula to find that sum. So the infinite geometric series formula for the sum is a sub 1, the first term, divided by 1 minus the common rate, 1 minus r. Alright, so let's practice using that formula a little bit. In order to plug into that formula, we need to figure out what a sub 1 and r is from our summation notation. So remember that the summation notation is using the general formula, a sub 1 times r to the n minus 1. So if we remember that, then you can find a sub 1 is equal to 2, the first term in the series, and r is going to be 0.01. I'm sorry, 0.1. Now I have everything that I need. So I can say that the sum of this infinite series is equal to a sub 1 divided by 1 minus r. Plugging in a sub 1 and r, it's 2 over 1 minus r. When you do this in your calculator, be very careful that you put the entire denominator in parentheses. 2 divided by 1 minus 0.1. Or you do the denominator first and get 0.9, so that you make sure that you get the same answer, 2.2 repeating. You could also give me that sum in a fraction as 20/9. That is the sum of this infinite geometric series. So we were able to identify a sub 1 and r in the first example. On the right here, we also need to identify a sub 1 and we need to identify r. If you can't already tell what the common rate is, a good way to find it is to take the second term and divide it by the first term. So take the second term of 4 and divide it by the first term of 12. And reduce that fraction and you'll see that the common rate is 1/3. A sub 1 represents the first term, which is 12. So now you have everything that you need. So S is going to be a sub 1 over 1 minus r. So a sub 1 is 12 over 1 minus 1/3. Which is 12 over 2/3. Or if you're going to put this entire thing, this thing in your calculator, you need to be careful to put your parentheses. So you do 12 divided by parenthesis 1 minus, in parentheses again, 1/3. Close your parentheses. You should get 18. Please take a minute and practice that, getting that put in the calculator correctly. If you did 1 minus 1/3 first and got 2/3, 12 divided by 2/3 should still give you 18. The sum of this infinite geometric series, so even though it's going to get infinitely smaller, if we took all those terms and added them up, you get 18. These sums specifically exist because my r was less than 1. 0.1 is less than 1. 1/3 is less than 1. So we were able to find the sum of the infinite series. Next examples. Here in the summation notation here on the left, we also need to identify our a sub 1 and our r. So remember that general formula, a sub 1 times r to the n minus 1. So our first term is 3, and your r is 2/10, 0.2. 0.2 is less than 1, so the sum exists, in which case you can use the sum formula, which is the sum of the infinite series is a sub 1 divided by 1 minus r. Plugging in 3 for a sub 1, plugging in 0.2 for r, looks like that. If you do the denominator first, 1 minus 0.2 is going to be 0.8. And 3 divided by 0.8 gives me 3.75, or as a fraction, 15/4. All right, the one on the right, we need to find the sum of this series. We first need to find a sub 1 and r again. So a sub 1 over here is going to be our first term. That's going to be your 3. R, if it's not completely obvious, again, take the second term and divide it by the first term. R in this case gives me 6 divided by 3, which is 2 over 1, or just thinking of that as 2. So if you think about our r being 2, we have 3, 6, 12, 24, 48. It's just going to keep doubling and multiplying by 2. The r is not less than 1. 2 is greater than 1, in which case there is no sum to this infinite series. We can't find it. It's just going to get infinitely large, in which case we cannot find the sum. R is not less than 1. Okay, what do we do if I give you the sum and the first term? Can you find the common ratio? So you're using this formula, S equals A sub 1 over 1 minus R. And I'm telling you the sum, S, equals 12, and the first term, A sub 1, equals 6. I want you to find the R. So let's plug in what we know and see if we can solve for R. So the sum is 12, A sub 1 is 6, 1 minus R. In order for us to solve this with the R being in the denominator of the fraction, we're going to have to multiply both sides by that 1 minus R. Because now we have 1 minus R in the numerator, 1 minus R in the denominator, that will cancel. On this side, we'll just get 6. Over here, when you have a whole number times a quantity, you have to use the distributive property. And you will have to distribute the 12 to the 1 and to the R. So 12 times 1 is 12. 12 times negative R is negative 12R. Now use inverse operations algebra skills to solve for R. So I'm going to start by subtracting 12 on both sides. I'm going to get negative 12R equals 6 minus 12 is negative 6. I'm going to divide by negative 12 on both sides, and I'm going to get R equals 1/2. And that was the question. Given the sum, find the ratio, which is R's 1/2. Alright, we're going to do another one like that. So, we're using the same formula. The sum equals 1 minus R. The sum I'm giving you is 30. The first term, A sub 1, is equal to 2. Find the common ratio. So let's plug in what we know and solve from there. So we know S equals 30 and A sub 1 equals 2. So we start with that formula. Then we need to find R. So we multiply both sides by 1 minus R. Over here, 1 on the top and 1 on the bottom will cancel. It simplifies to just 1. So over here you get 2. Here you have to distribute the 30. 30 times 1 is 30. 30 times negative R is negative 30R. Then solve for R. Start by subtracting 30 on both sides. So we get negative 30R equals negative 28. Then divide by negative 30. I'm going to move this up a little bit. R equals negative 28 over negative 30, which can be reduced. That's going to be positive 28 over positive 30 because two negatives will cancel. Then these are both divisible by 2. So, final answer, 14 divided by 15, or 14/5. So R equals 14/5. 14/15. Okay, the last one, I'm going to do it in writing and I'm not going to talk. That will give you an opportunity to try it on your own, work it out. Look up and make sure you check your answers as you go. And when we're done, you can start on the 11.4 worksheet. But I want to make sure that you have gotten the right answer before you move on too fast. So I'm going to do the work up here and you're going to start it down there. All right, make sure you check your work. Make sure that you have gotten our common ratio of 3/4. Since I'm telling you that this geometric series has a sum of 16, has a sum of something, that means the common ratio that you get must be less than 1. So if you have an answer that is greater than 1, you've done something wrong. So that should be a good indicator. And then you can always plug it back in to check your work. So plugging it back into 4 over 1 minus 3/4, and that should give you 16. All right, homework 11.4. So we're on worksheet. Thanks, guys. See you tomorrow.